Hello everyone, my name is Shockley. I am a robotic engineer in D-robotics, and today I will show you something about the RDK Studio and most CLI in this office hour. And these are amazing tools for all of us to build robot robotic, and let's start it. So in today's office hour, we we will solve some problem come from our new community questions. For example, some people may ask, should I use Ethernet or Type-C? Which IP should I ping? Why does Quick Connect doesn't work? Or what is the Pro agent tracking? So in today's office hour, we will solve this problem step by step. So this is today's agenda. First, we will take a look at RDK Studio as a workspace. Second, we will go over the connection method, Ethernet and Quick Connect. Third, we will plan the differences between most and on your PC and open cloud on the edge. Fourth, we will talk about agent skill. And fifth, we will jump into the most CLI for those of you who prefer to use the terminal. And finally, we will run some live vision demo directly on the board. Next, and let's start. Let's start with the RDK Studio. It's designed to be an all-in-one workspace for our robotic project. Historically, embedded development was a bit of mess. You need to serial connect FTP silent currents and analyze documentation tab open at the same time. And we wanted to create an experiment that was unified and AI native. So Studio bring your terminal, your file, your flash tools, and your broad control into the window. But the real game charger is how you interact with it. Instead of searching for complex Linux command, you can just speak to it in your language. You can type how hot is the BPU running. The agent can understand what you want and run the Y command and give you the answer. It saves so much time. And if you want manual control, the UI is right here. If you want a faster workflow, you can just ask most. So basically, the RDK Studio is have a is an interface is built on three very straightforward layers. On the left, you have your core system tools, the connection, flash, and extension. Across the toolbar, you have instant visibility into your device connection status. And the entire bottom is dedicated to modes. We lay it out this way so your workflow is never interrupted. Everything you need is right in front of you. But before we can really use modes, we need to reliable connection. In Studio, everything runs through one single device section. If the connection drops, everything drops. So we have a very simple rule of thumb. Always ping the SH first. If you are connected on internet, your target IP is usually 192.168.127 and 10. If you are using Quick Connect, the 7 should be changed to A. And we give you three ways to connect depending on your choice. The first way is standard Ethernet. You plug it into your Ethernet to your PC and you use that and you use this IP address. And the second reconnect is using USB cable Type-C. This is great for mobile developer because it creates a direct virtual network link. No router is needed. And they use the 128 address. And the source is local zero log, which is our fallback to detect some hardware debugging. For example, if your RDK can put into the system, you can connect our server logs to see what happened. So next step is go to the subnet setting. If you are using internet, your PC must be on the same subnet as your board. You just need to manually set your PC subnet PC IP like this what IP address. With quick connect over Type-C, we also need to set the IP address, but the 127 need to change to 128 because the RDKXY IP address is static. So let's take an example to how to set the IP address to fit the RDKXY static IP. So if you are using Windows, you can open the setting and open this network and internet and open this internet page and edit this IP setting into menu and click your IP address like 100 as your computer IP and your subnet mask must set to this one. So you need to click save. And because I'm now using quick link to connect RTKX5, so my IP address is 128.100. So before you set this IP address, you can connect our RDKX5. So let's move into the next part. Yes, this is the Type-C Quick Connect. The difference between Type-C Connect and the Ethernet Connect is the IP address is different. So you must pay attention of this. So if you're setting your IP address in your computer, you can access our devices via SH. And also our studio also have a SS function, so you can use our studio terminal to connect our RTK-X5. So then next, so for example, I have already setting our IP address to suit the RDK-X5 IP. So I can create this onto RDK Type-C directly connect and create this virtual Ethernet. So I can click this button start connection and just wait a minute. And as you can see, we have successfully connect our RDK-X5. So this is how RDK, how our computer to connect RDK-X5. And the next one, let's move into most in RDK Studio. There's a important distinction we want to make today about where the AI actually live. When you use mouse in Studio, the intelligence is actually running locally on your PC, and it uses SS to connect the RDK-X5 and send some command to the board. So this is great because this means the RDK board doesn't need to waste any resources to running agent software, and you just talk to the agent on the PC, and the PC agent will send some command to RDK-X5 to execute some program. And because everything flows through one program, the experience is highly integrated. You can ask most a question, open the VNC viewer to see the displays, and check the logs in the terminal. All at the same time, it creates a very smooth development loop. I'd like to also to show you some simple of how to fetch our RDKX file. You won't need this function every day, but when you have a new board or need to complete restore your OS, it's very straightforward. You just pick your image and fetch button so that you can back up or running so that you can fetch a new RDK board. And now we get a lot of question about the differences between the MOS and open cloud. So they share the same underlying technology, but they serve two different purposes. MOS is your companion on your PC. When you when your laptop goes to sleep, MOS stop. But open cloud, however, live entirely on the RDK X5. It runs natively on the RDK hardware. So open cloud is optional, but for stand but for a long deployment, it's incredibly useful. If you just want to sit at your desk and chat with MOS, you do not need to install the Pro agent. If still if the studio say the Pro agent is not installed, your board is still healthy because the MOS can also control your store, your RDKX file. And but when you want your board to have autonomy after you walk away, that's when you install OpenCloud. Here's an example of what made OpenCloud is so useful. Because it's live on your board, so you can integrate it directly with instant messaging like Telegram, WhatsApp, or Slack. You could be away from your desk, pull out your phone and send messages to your robots asking, is the camera still running? And the bot agent will check the hardware and text you right back. You can also set up schedule tasks like an hour healthy check that automatically restart a falling rose node, or it turn the RDK into an autonomous edge devices. To give more to give most and open clouds this capability, we use something called agent skills. Agent skill isn't a massive new AI model. It's simply a prompt. It teaches the agent exactly how to interact with the RDK hardware. When you get your board, you just go to the skill hub and install the camera network and GPIO skills. Once they are installed, your agent instantly know how to control the physical world. We also know that the privacy is a big deal for a lot of robotic developers. By default, most leverage cloud API for performance. But if you are working on a confidential enterprise project, you might need to totally data privacy. That's why we build local model. So you can deploy the local model via this function. You can deploy like Gemma 4, String 3, and Olama or other large language model totally just use our RDK Studio. Okay, next is some studio example. We can use our language to ask most to run a YOLO object detection on our RDK X5 so that they can break down this natural language to different commands. And finally, it will display the object detection via the web and show in the RDK Studio. However, Studio is a UI software. If someone don't want to use RDK Studio, they want to use some AI agent in the terminal, we also have another tools we call Most CLI. Let's take a look at Most CLI. If you live inside VS Code or your terminal, the CLI bring the exact same AI bring directly into your local environment. It can read your file, check your Git status, and help you debug without having to switch different windows. And install most CLI is very simple. You can just run this command, and it's very easy to deploy the most CLI in our RDK X file. So the RDK, the most CLI has different type of function. The first one is connect to the board. If you run most CLI in your PC, you can use this function to connect RDK X file. You can just type this connect, and following is the RDK X file username and the IP address. You can remember the RDK X file address, and so that you can access to the RDK X file to execute some command easily. And the second function is you can attach some folder or some files to the agent so that they can understand the project. And then you have some memory and skill, especially for the RDK X file, like how to use camera, use to node, and some RDK, especially command like dig check. And you can ask most CLI to RDK X file to a healthy check. So let's have a 5-minute demo to run a PYDV demo directly from CLI. The PYDV demo is in our RDK X file images, so we can access this demo without any downloading. And in the next part, we will show you two demos. The first demo is using most CLI to run ResNet 18. And the second demo is use most CLI to help us run UNO. Just like this one, we can easily run our RDK official demo with our most CLI. So let me do some practice experiments. Let's open our RDK Studio and open our code editor. And as we open our code editor, it's just like our VS Code. We can detach this IDE, and it will free of the RDK Studio windows. And now we have connect our RDK X file, and we can just, because I have already installed the most, so we can just type most to launch our agent. As you can see, this agent is just like cloud, but our demo isn't in this folder. We should see it in our app folder. We have a lot of demo. For example, the 40-pin sample tell us how to use the 14 pins to connect some sensor in the RDK. lighting the LED light, and the CDDV demo help us how to use how to connect our camera. We have different type of camera, like USB camera, MIDI camera, and this demo teach us how to get the video feedback of this camera. And the other one is PYDV demo, and this today is our material we will use today. And actually, it is some Py- Python script. With some Python script to run some AI model like classification sample, ResNet 18, and MobileNet, and the detection sample now you know, and the post detection sample, and the segmentation sample, and USB camera sample. And in today office hour, we will show the first and second sample via our most CLI because this sample is in an early stage. The README is only in Chinese, so we can use our mouse to help us understand in English better. For example, we can ask mouse CLI to run the ResNet 18 sample. We can just type help me run the ResNet 18 classification sample and e- and explain the output and the process for me. And as you can see, it's thinking. Most can navigate to the directory and execute the Python script. So now most is reading our file and our directory. So with this powerful most CLI, we can easily to finish this RDK challenges stage 1. To run an AI model sample. And all of this AI model sample, the documentation of this AI sample is in our RDK RDK documentation website. This is increase start. Yes, it's in the algorithm repository. And you can visit this website URL to learn further about this sample. So let's go back to the most. As you can see, most successfully mm, launched the BPU to inform our ResNet model. Oh, it has some inform error, but the most can fix this error automatically because it can see the feedback, error feedback, and think in, in another time. Okay, as you can see, it has successfully output detect answer. It detect the algebra, and what we have put the model input is photo. Yeah, it's a debug photo, or maybe the VS Code in the RDK Studio isn't suitable for our developer use. We can launch another. We can run the we can use the VS Code to connect our RDK X5 because it can also because it's the early stage of our RDK Studio. It has still has some technical problem of this software. So as you can see, we have just put this camera, these photos into ResNet detection Python script, and the final result is to detect the Java, and the possibility is 99% percentage. And the second demo is use our mouse to help us run you know V8 model to detect to use our USB camera to detect something. Just now just now we run the ResNet 18 model. We can use our mouse to help us run this model more quickly. Let's open our terminal and launch the mouse. And mouse basically have many functions. For example, the statue function help me help us better know the statue of RDK. And the second function is to set a goal. And if you set a goal, the mouse can run the project mouse can run automatically until it achieves this goal. For example, the mouse will launch, launch multiple sub-agents, and each agent have different thing to run. And finally, to this multiple agent will cooperate together to achieve your goal. And in this demo tool, we can just ask mouse to run a model, for example. And for example, you can ask mouse, can you run uh you know object detection with my USB camera? And also you can attach our folder to our mouse. Okay, let me directly input the sample path to mouse. Maybe the mouse have some technical problem. So let's try again. Because I have I have assembled a string in our RDKX file so that we can display the detection result in our screen. So let's give the mouse some light so that it run. So as you can see, it can read the file di directly and think out to execute. So in recently web coding is very popular. So I think that tools, most tools can help us coding have more efficiency. So for the user motion wise. So as you can see, the mouse can find the V8 model path and inform this and inform the model to our BPU. And as you can see, this is the final result of this command. I have run it yesterday, and I used a USB camera to get the video feedback and display the detection result in this tiny screen. And if you are interested in this screen, you can buy it through this website. So let's have some conclusion. The most has different commands to help you better use of these tools. And we can use statue command to get the RDKX5 statues. And we can use model command to switching your AI agent or using your local model. And the go command is very powerful one. You can fix what you build and you can reach your goal automatically. And the help command is also useful because it can help you better understanding what most can do and what most is. And this install reference, you can run this command in our RDKX5 terminal to install the most in our RDKX5. So this is the end of this office hours sharing about the RDK Studio and our most CLI.